Swayam Prabha. Digital India. Educated India.
The importance of safety requirements in the productivity and management of coal mines cannot be overstated. These requirements form the foundation for protecting human life, ensuring efficient operations, and maintaining long-term sustainability in a high-risk environment. Today we are going to meet the team of innovators that worked on this subject and won the SIH 2024. So welcome to the show, guys.
Thank you, sir.
Thank you, sir.
Good to have you
Yes,
today
sir.
with us. So please, if one of you can introduce us to your team.
Yes, so my name is Prathamesh Sane, and I was the team leader for Team 42 Hackets. Then we have Veer Shah with us, Muskan Sharma, Khushi Parekh, Heenal Patel, and Sanjeev Ratnani.
Okay, so to start with, let's try to understand the problem first. What was the exact problem that you worked upon?
So this problem statement was given to us by the Coal Ministry of India. And as we all know that coal mining remains one of the most hazardous industrial sectors, the main problem was of the safety management issues that were being faced in the coal mines of India. So, ineffective hazard reporting mechanisms or the safety management plans that aren't easily accessible during emergencies. Then also one of the major problems was the fragmented information flow between shifts. So the shift workers had to fill out manual forms after every shift and hand it over. So the flow of information was very rigid and non-software. So that was one of the major two problems which were identified in the PS. Then also what we found out that there was a limited use of real-time monitoring systems for environmental conditions, also absence of data-driven insight for risk prediction and prevention. Then to adhere to the DGMS guidelines or any other guidelines for that matter, we had created a PDF query bot so that it enables the coal in charges to adhere to those.
Okay,
basically,
so as far as the problem goes, it really looks like it is definitely a big problem because the mining sector is huge, and the number of mines or number of people working in those mines is also huge. So till now, I mean, as per your basic research or some information gathering, what is the enormity of this problem in the sense the number of people in terms of number of people or otherwise? What is the enormity as per your findings?
yeah, the severity was quite high because taking into consideration that India had to meet a coal production target of 1.5 billion tons, these little gaps in the flow chain or the supply chain of the coal mines were kind of disabling the production of the coals. So, to identify these problems and to solve them were quite a challenging task for us, but yeah, we sure tried our best to do it.
Yeah, I'm sure you did because you created something which won you the competition. So now we'd like to know just that. What exact solution did you come up with?
Yeah, so for the exact solution, Sanjeev will take over.
So this is a key solution, which was Dhara. And what we observed coming to this problem in the journey we went through was there were two main things we had to tackle. First was streamlining the entire digital process to enable our mine managers and our shift in charges to become friendly with the technological stuff we are trying to portray. And the next step was increasing the safety with data driven things. So what we tried to come up was first having an ML driven analytics system. So not just any randomly making of SMP, what we came up with was features such as SMP enhancer with AI powered inputs. So based on other previous safety management plans, whenever you are creating your SMP or uploading your own SMP which you currently have, this was a key issue that the people don't realize when their SMP are becoming outdated, what new changes are being happening, if there is another risk happened at a particular mine. If they have found the solution for it, the other mine doesn't get to be aware of what current new situation they have tackled, and so they are unable to include it in their current mine within the offline system. That's why we put this entire system into an online mode and connected all the mines with each other. Next up, emergency response system was a crucial aspect of this. So that's why we also integrated IoT sensors into our solution. And based on the key IoT sensors values, what another key feature we had put was automated calls to the mines manager. So when any value is detected which is very hazardous, that automatically conveys a call to the mine manager, and he or she is informed what is the issue going on beneath the surface. We also came up with interactive blueprint analyzers. So what this did was, we noticed in several sections there was an issue. If a machine is on in one particular area, other users were not being able to aware, other mine workers were not aware that this is a high risk zone. So based on your mine's blueprint, it converts it entirely into a segmented map. And then when any area has started any particular work, you can just go onto the application, mark that map, mark that area in the application as some work is going on or whatever is going on in the procedure. So it is an hazard prone zone currently, so that the other users are just immediately informed that to not enter this zone. This was a key issue we saw people facing. Even with geospatial risk mapping, one of the SMPs I was personally going through during our research journey, we faced that so in one SMP it was written, if in case of a fire, go to this particular office and then retrieve the map and then move ahead with the solution, then try to tackle. So this entire process in case of a fire hazard, there is no time to address so much of things, going through so much of a manual procedure. So that's why we just digitalize this entire thing, and on one click you can just get your entire escape route, entire risk mapping is done ahead. For the ahead ML features, I'd like Veer to continue.
Yeah. So we basically developed the SMP analyzer. So what the SMP analyzer did was, people creating different SMP documents, but people don't know what the SMP documents really look like and what the structure of the SMP document is. So we were providing what the structure of the SMP document is, and based on that, the SMP document is created, and also we were giving them points that how much efficient their document is. So that was the major part of the SMP analyzer. And second most feature was the segmentation part. So how the Sanjeev explained about the evacuation plan, the ML model took the input of the floor plan of the mine area, and basically what the ML model did was it segmented the area, and it provided which part of the area is dangerous zone and which part is not. So that was very efficient for the evacuation plan. Features were IoT sensors. So what we did was we created the hardware part which seemed to be the IoT sensors, like it was reading the real-time monitoring on the mines, and we were judging that how the currently mines are having the gas level high or pressure level high, and so on.
So one more thing which we implemented was, this was based on the mentor's suggestion was, so we realized, the mentors made us realize actually, that these mine managers get a huge forms of guidelines which are more than 50-100 pages, and they need to go through all these guidelines, and once they are done with all these guidelines, they need to just implement and understand these within 1 to 2 days. And getting so much of information absorbed in so less time becomes very difficult task for them. So what we try to come up with a solution, we try to come up with a LangChain based model, which what it did was, the entire PDF, you can just query anything you want to ask about it. It will give you an explanation on it. It will give you a further enhancement on it. elaborate on it, as well as tell you the exact line and exact page where that information is present. So you can just go through the entire details of the actual technicalities of it as well. And whatever you need to ask, whatever key summaries you want to tell, the entire part is reduced down to becoming at least 100 to 200% more efficient. More our journey and our entire solution being of web plus app, I'd like Hinal to elaborate on it.
So we have seen that earlier creating and managing the SMPs was completely manual and it was completely paper based. So which was very much time consuming, and also it was very difficult to update that and save the records. So what we thought of that we built an online system that makes this process very much easier. It's just a simple form which the user needs to fill for creating the SMP. So in that we made it editable, so they can just edit their existing SMPs, update that. Also they can create new SMP based on the template which we created. So after filling the form they can just directly download that in PDF format, so which they can share. Also users can fill a simple form for checklist. So SMP is automatically generated and saved. And also for checklists, so before proceeding for a task which is hazardous, so these checks are made. So earlier that was also completely manual, so saving that time and effort, we made that completely online. And also on our dashboard we kept a weather feature. So what it does is that it gives weather based safety alerts, like using the live weather API. So since these mining operations are affected by sudden weather changes like heavy rain, heat or storms, so our system fetches real time weather data and gives the safety alerts or recommendations based on the conditions. Also in the dashboard we had a graph which tells you that what is your coal production up till now, and at what rate you can increase it to meet the actual target which you are meant to be. So that was all. Now I would like Khushi to proceed.
Yeah, so one of the other features that we implemented was multilingual, as India is quite diverse in terms of languages, and also we have kept accessible in offline mode using Redis and all. So the technologies used were Flutter for app, Python for the ML model, TensorFlow, Redis for the offline mode, React for the web-based, and Firebase for the backend, Node.js, Provider Express, and PyTorch.
Okay, your technical stack also looks pretty, sorted. So now what comes to my mind is key, of course, I mean, being an SIH project, you wouldn't have been able to take it to a mine and, actually put it to you can say test or something like that. So how are you able to validate it? How are you able to ascertain that it really works, or how are you able to convince the judges that, okay, this is the workability is not questionable? How did you do that part?
So what we tried to do was we tried to simulate an environment. So even though we were from the software theme, we also included some form of hardware. We included our own IoT sensor. So what we tried to do was we integrated one particular sensor and we tried to mess up with its values and see how it responds in a controlled environment as well. So what we showed in the first mentoring to our judges only, we showed our sensor being integrated into an environment, and then our system architecture was laid out in such way that multiple sensors, how many ever you want to connect, we use the standard industry protocols what are used to communicate with these sensors as well. So the entire architecture was such that even from a small demonstration, it is easily adaptable to a much larger system as well. Also, to connect with such a large system, Coal Ministry and the Coal India Limited have their own ERP. So that was a crucial aspect of the problem statement as well. So our entire layout, even for that, we created a mock server, we created a mock ERP system in which any update happening on our system reflects it on the ERP system as well. And this was what the judges liked from the get-go of our solution as well, that our ERP had an entire layout and it was perfectly laid out with how they wished it should be in the current stage, because we cannot work with the actual data for now. So just to simulate this entire environment of what will be happening in the actual thing, and just to make judges realize the potential of our solution, we went ahead with creating a simulated environments and creating mock-ups of everything which will happen in the real environment. So that way, the judges were able to correlate, okay, if this is working at such scale, with time, if we scale it up properly, it could work ahead as well.
Not only creating a solution, but also creating the simulation for it, creating an environment wherein you can showcase the solution. That was some very good work done. So now this takes me to a question where, the interaction between you and the mentors and the judges, how did that go? I mean, from the very first round till the very last round, how did that, pan out? Were there suggestions? Were there, some areas in which you had to, kind of go back and rework on things? What all happened there?
Plenty of our features came due to the suggestions of the mentors because they knew better about what was going on in the coal mines, and they were able to inform us to make changes to our products in a very timely manner. For example, they we had already implemented the multilingual support in our web app Thara, but they also suggested that OCR could be a possible cause where we upload an image of an existing SMP and it is able to configure it into a document that is ready for us to edit. Then SMP creation and editing was also something that was suggested to us by the mentors, the judges, the different rounds. Furthermore, the PDF resolver, which is one of our important features, that was also suggested by them because from what they thought that it is not possible to go through several databases to find an appropriate instruction, and sometimes these instructions tend to conflict about what we should do in a particular situation. PDF resolver solves that problem very efficiently. So we had a very good relationship with our mentors and judges, and they were able to alert us about the different features that we should possibly put into Thara. And because of the support, we were able to achieve such a quality product.
Okay, that's great. Wonderful to know that a lot of inputs from the judges actually got converted, and that led to the betterment of the project that you worked upon. That's so nice. So, any other incidents or any other thoughts that you would like to share in terms of your experience at SIH? How did it all went through in terms of the environment, in terms of the people around you? How did that go?
The environment was pretty nice and competitive at the same time. Like the teams were talking to each other, were congratulating even after, but there was a healthy competition between all of them. And also the mentors of the team which had come, they were also quite friendly with us. Even after the win, most of the other TS mentors came to us and they congratulated, and we did the same. So it was a healthy environment which led to a great innovation and great cause.
So good to know that you came through this environment which was very healthy and supportive and went on to win the competition. Now, here I would like to know a little about the future plans that you might be having. So, what have you thought? Like, how do you like to put this thing forward? Do you think you can monetize it, or anything else that you would want to do this to take it further?
Okay, so when we created Dhara, our vision for it was that Dhara should not be built just for today, but for the next decade of mining innovation. So one thing we put into it was wearable tech integration, and in the future scope, we could have Dhara connect with smart helmets or biometric wearables to monitor fatigue, heart rate, posture in real time. So offering predictive alerts before accidents happen. We are already using IoT to detect gas leaks and such. So we could take it one step further. Then drone-based mine surveillance is another potential idea. For example, we can use autonomous drones so that we can enable aerial inspection of remote or unstable zones, which will reduce risk and speed up the hazard detection. Then generative AI for incident analysis to auto-generate detailed incident reports, mine audit summaries, and event training simulations. For example, we already provide options to create and edit SNPs. We could take that one step further. Then ERP and DGMS integration. We envision full dependency and interoperability with Coal India CRP, of which we provided small section already in Dhara, and DGMS systems. So that will enable centralized compliance tracking and seamless safety audits. It will have a modular and scalable design. Dhara's architecture supports plug and play modules. We also have offline functionality for deep within the mines. We could operate within it. And an important statement which was present in a problem statement was India's coal mining future for 2030 and beyond, which is the target of 1.5 billion tons of coal production. So this is a long-term goal, finally, to position Dhara as a unified command and control center for mining operations, where we transform safety and productivity on a large scale. With the right support, we think Dhara can power a safer, smarter, and more sustainable mining future.
Yes, of course, said it really right. It can, of course, create a very good, very safe environment for our miners, and I'm sure people will take notice of this, and this innovation of yours will go miles, will create a big and large impact. So, guys, thank you so much for joining us today and sharing with us your work. It's really wonderful, and of course, did deserve a win in the competition because you worked hard, you used the right technology and right resources and right manner of presentation to be able to win the competition. So congratulations once again on that, and I wish you all the best for your future endeavors also. And I'm sure I'd like to see this happening, actually getting implemented in some of the areas in the very coming maybe if not days, maybe months, or maybe at least a couple of years. It should be there in a workable condition, and we will remember you when we see that happening. So all the best, guys. Thank you so much for joining us today.
Thank you, sir.
Thank you, sir.
Technology can indeed play a huge role in enhancing both safety and productivity in coal mines by enabling smarter decision making, real-time monitoring, automation, and risk reduction. The work done by these young innovators will go a long way in making our mines safer.